The most effective data scientist, the one that I cannot do without, and the one that's really scarce, is the people who can communicate. I was really surprised because I thought, hey, everyone can talk, everyone can write.
Yeah.
What is the big deal about communication?
Hello, everyone. Welcome to the Data Scientist Show. Today we have Eugene Yan. Eugene is an applied scientist at Amazon. He's a part of the book organization where his mission is to help customers discover and read more books. As an applied scientist, he designs, builds, and operates a machine learning system that serve customers at scale. Previously, he led a data science team at Lazada, which was later acquired by Alibaba. In his free time, he writes and speaks about data science on his website, eugeneyan.com, with 2,050 subscribers. Today, we'll talk about his career journey and his best advice to build a successful end-to-end machine learning project. Make sure you stick to the very end where he shares his secret sauce in his career development and productivity. Welcome to the show, Eugene.
Thank you for having me here, Daliana.
So what's your career path towards working with machine learning? How did you get into the field?
Yeah, it's a it's a pretty interesting path, and I don't recommend other people try to replicate it. So what happened was I graduated with a degree in psychology. Why I did that? Because I was really interested in how people think, how people perceive, and how that causes them to behave. But right out of school, I wasn't sure what to do. So I actually joined the government as an investment analyst. But 2 years in, or about 1.5 years in, I started to really miss working with data again. So I did a couple of SQL courses online. From school, I had my R and statistics training and experiment training. I did a few interviews, and I was really grateful that IBM decided to give me a role as a data analyst. So I started there as a data analyst, initially at the supply chain center, and I was also working on a bit of social media analytics. A year in, they offered me a more permanent role as a workforce analytics, part of the workforce analytics team. So what I was doing there was I was trying to forecast what jobs were going to be in demand in the future. And at that point in time, it was things like cloud, iOS, mobile developers, etc. So to tie that in, we actually built an internal job recommendation engine to try to recommend people jobs within IBM to get people from more obsolete skills to transition to some of these more recent skills. And 2 years into Lazada, funny story, I did a Kaggle competition with a friend. We did pretty well. We were in the top 3%, and someone just said, why don't you just present it at a meetup?
Yeah.
And we did. I mean, it was a young meetup. I was happy to contribute, and we contributed. And it turns out that there were some people from this startup, it's called Lazada, that were there, and I was presenting about my solution for product classification. And Lazada, being an e-commerce startup, they were really interested in that as well. So someone there heard about my solution for product classification. I got invited in for lunch. When we went for lunch, it was a dinky, I think 2 or 3 story building, very rundown. And the team was only like 2 or 3 people. And again, I presented how I did the product classification in the Kaggle competition. And then they asked me, hey, you have this, you have product titles.
Yeah.
It's in multiple languages, including Vietnamese, Indonesian, Malaysian. How would you do it for us? So I spoke about my solution, and I think then we went for lunch, and I got an offer for that. And at the point in time, it was a startup. I'm not sure how it would have gone. And my parents were, and my girlfriend, now wife, were also suspicious. Like, are you really gonna leave IBM to go to this startup? We've never heard of it. At that point in time, no one has heard of it. But at the point in time, I was, let's try it. Since I'm young. I mean, even though, and for listeners out there, you might not be young anymore, but if you haven't done a startup before, I still encourage you to try it. So I did it anyway, and it turned out to be very well. It's super fun. I learned a lot. We made a lot of great friends. We still have a Lazada Data alumni chat group. It was a great fun. And after I joined a few years in, we got acquired by Alibaba. And then I joined, after that I moved on to a health tech startup. again in Southeast Asia, but I think the industry wasn't quite ready for that. So then after my wife and I, we want to get out of our comfort zone, so we started looking for opportunities outside, and one of the opportunities happened to be Amazon in Seattle. So here I am, part of a great team where, I mean, the mission really attracted me, which is to help people read more. And the leadership principles really appeal to me, which is starting with customers and then delivering results. That's the last leadership principle. We have 2 more now, but previously there's the last leadership principle. So here I am.
Yeah, thanks for sharing that. Definitely want to ask more about the lessons in your career and what factors helped along the way. But let's start with your day-to-day job right now. So what do you do every day as a machine learning engineer?
Well, I think this would differ across different projects and across different roles. But at least for me, the bulk of it is actually spent design and implementation. So what does design mean? So design means that, hey, you get an ambiguous question, you get an ambiguous request, and you sort of need to try to talk with the stakeholder. Okay, you want me to, let's say maybe the stakeholder, you want me to classify products. Okay, does it need to be real time? Does it can it be in batch? What are different languages? What kind of input will you give me? What kind of output do you require? What kind of performance do you require? Is it top 3 accuracy, top 1 accuracy? Is it recall precision? So that's really framing the problem. And after you frame the problem, it's researching what other people have done. I mean, product classification is not a new topic. Companies like Walmart, Amazon, multiple companies have published how they try to do it. And then after you've come across these multiple solutions, maybe you prototyped it, you write a 1-pager and you get all the metrics aligned. That's when I recommend you write a design doc. So that's what we do in Amazon. I think we call that 6 pages, where you talk about the context, what the deliverable is, as well as how you're going to solve it. And as you're presenting how you're going to solve it, right, you share this with people and people are going to give you feedback. Can this be simpler? Can you reuse this? Have you thought about the cost? Can you lower the cost? Etc. So that's a design phase, and actually that's a big chunk of the design phase. There's a big chunk of it. Then after that, there's the implementation phase. Okay, so your design, you've gone through multiple rounds of feedback. People seem pretty happy with it. It's as good as it can get with things on paper. Then now you have to start to write some code and start to see how things go. So that's the implementation phase. It usually involves things like Spark pipelines, writing data pipelines, building machine learning models, deploying machine learning models either on SageMaker or in batch, or running them in Spark. And then once your machine learning model is live, you have to put in monitoring. So for example, hey, if it needs to be real time and the errors are you have a alarm for how many errors you get per minute, and if it exceeds a certain threshold, you want to cancel that. You want to be alerted, and then latency metrics and throughput metrics. So that's what I mostly do for design and implementation. And of course, a big part of it is communication, right?
Yeah.
I mean, we have daily stand-ups within our team, and within the scientists in our larger organization, we have once every 2 weeks, we go through a paper together, so that at least we have this shared context. Hey, this is a paper that someone found interesting. They present it to us, and then we try to think, hey, can this be applicable? What lessons can we draw from this that we can apply to work? Also, once every 2 weeks, or whenever there's a new project, we take our time. So I just shared about how I would write a design document and share with the team, right? The same thing. People will write design documents, and it is I have to read it and provide feedback. So that there's quite a bit of communication going on as well.
Yeah. So basically your day-to-day is depending on which type of, what kind of project cycle you're in.
Exactly. Early in the start of project cycle, it's going to be heavily design. And in the later part of the project cycle, it's mostly implementation and operations.
Right. And I love that you shared some tools you use, like SageMaker, Spark. Can you give us more insights about the tools you use?
Sure. I think for big data processing, for ETL, I think, so for small data processing, you can't get away from a SQL. So for everyone who doesn't know SQL yet, or it's not very good, I highly recommend it. And for big data processing, I think most companies that I'm aware of are slowly converging to Spark, or maybe some Snowflake or dbt. So in my team, we use Spark a lot. And we have a nice internal approach whereby it includes scheduling, dependency checking. For machine learning models, I mean, I tend to favor PyTorch, and I also rely a lot on my trusty decision tree libraries, including XGBoost and like GBM. I love those. They're really fast to train, and they get pretty good baselines right off the bat. But sometimes for image stuff or text stuff, deep learning is still better. And then, so maybe one thing I like to do is, after I build a model, I like to demo it. I like to make it real for our product managers or stakeholders. When that happens, so I try to I try to hack together something with Fast API, which is beautiful. Or you might also use Flask. Previously, I used Flask. I've seen move on to Fast API. And just some simple HTML and CSS, maybe a JavaScript. That helps make the machine learning model very real, right? They can see it, they can interact with it. So that's a big plus. I think besides that, if I need more infra, I mean, clearly, obviously, I use SageMaker. So if I need more infra than my MacBook Pro, I need more CPU cores, I need more RAM, or I need GPU. I just turn to SageMaker, and SageMaker through Jupyter Notebooks through the SageMaker Jupyter Notebook makes it easy to spin up a SageMaker training instance or whatever, and just use the GPU or whatever infra I need. So I think those would be the bread and butter tools that I use. I guess a couple of tools that I also use, I mean, Jupyter, I think everyone uses Jupyter, 99% of data scientists I know. I also use MLflow for tracking experiments. I love that. And I think that's about it.
Cool. Thanks for sharing that. So now let me ask you this. If you have a new problem, especially when it's unfamiliar, how would you approach it if you want to, try to solve it using machine learning?
Yeah, I think I would start by clarifying the intent. So, for example, someone comes to me and says that, hey, I need to improve conversion on the website, right? And improve conversion. What is your intent? Is your intent to sell more units? Is your intent to get more new customers? Is your intent to increase revenue? For all this, you require a different kind of model, right? If you want to sell more units, you can sort of lower the price, or you can recommend lower price goods. You would sell more units, but you wouldn't increase revenue. If you want to get more new customers, that's more of an emailing campaign or marketing campaign kind of thing. So first, you clarify the intent. Then after that, you discuss about what is your desired outcome, right? And I just spoke about that. Hey, we want to increase, we want to get more new customers by maybe 10%. Or maybe you sell more units by 10%, etc. So that defines your metric. And then after that, there'll be certain constraints, right? Like what you cannot do. So if I want to sell more units, they could say, yeah, I want to sell more units. And okay, then can I lower revenue? Oh yeah, you can lower revenue by 5% as long as we sell more units by 10%. So that would be it. So once I finalize this, I will write it down in a document. I write it down in a one-pager. And then I'll circulate it and get people to agree on it, right? Get feedback, get people to agree on it. And once that's done, that's our roadmap. For the next 2 or 3 months, or however long the project takes, this is what we're going to try to achieve. And this is going to come weird from a data scientist. What I would first try to do is try to solve it without machine learning.
Yeah.
So for example, if I had to build a recommendation engine, my first baseline would be just a popularity baseline. I would just recommend what's most popular yesterday. And you can segment this multiple ways. What's most popular yesterday for that category? What's most popular yesterday for this gender? What's most popular yesterday across everything? So across everything, recommended you put it on the home page. For the category, you put it on category page or on the detail page of the item itself. And then once I have this baselines ready, I would then try to improve on it. See if I can improve it with some basic machine learning or even more advanced techniques if I have to. And once I have this prototype ready, I would then go into the design doc, right? Which is writing a design doc and getting everyone and getting feedback before I put it into production.
Yeah. And I love that you mentioned the first rule of machine learning is try to solve it without using machine learning. Can you share more about that?
Yeah, I think I don't think I was the first person to say this. I think I've seen it multiple times. I think Google's rule of machine learning, that's also the first rule in Google's rules of machine learning. I think what I see is that a lot of times in my previous teams is that when someone tries to solve a problem, they immediately jump to what's the latest and greatest, whatever was released at a conference this week or whatever was released in archive recently. And what ends up happening is that a lot of times the implementation for this is not clear. It takes a lot of time, maybe 6 months, 9 months. Whereas a very simple non-machine learning approach, maybe just some SQL and some rules and some statistics, can maybe get you 80% of the way there in like 10% of the time. And so what is great about not using machine learning and just a SQL statement is that, hey, you can very quickly launch something and test your customer reaction to it. Do customers really enjoy this feature? Do they really like it? And if they don't, that's great. It could be that whatever you built without machine learning is just not good enough. Or it could be that, hey, customers just don't need this feature. They don't even notice it. And if that's the case, you would have saved whatever time that you would have taken with if you had gone down the machine learning route. So I think that's what I recommend.
Yeah. I totally agree with that. And previously, you mentioned when you approach a new problem, you always ask the customer or stakeholder what's their intent. And sometimes, from my experience, they don't know what their intent is. They have a vague idea about what they want. So how do you work with business to identify and define problem suited for machine learning, especially when they don't know what they want?
I think that's a very difficult question. I think that it helps. Okay, so I can share with you my mindset.
Yeah.
When businesses come to me with a request. So my mindset when businesses come to me with requests is that I have too many things to work on. I'm lazy. And whatever estimate I have in my mind to solve this problem, I want to solve it in only half the time or even a quarter of the time. So let me share with you an example. In a previous role, there was this stakeholder who came to us that said that, hey, of the product ranking on the website, could you increase the rank of products that are fulfilled by Lazada? It's something very similar to Prime, right? So I thought, hey, that makes sense. I immediately came to the assumption, oh, of course that makes sense. We want to promote items that are fulfilled by our company, right? To get more sellers to sign on. That was an incorrect assumption. So I asked them, why? Why do you want to increase rank of this products that are fulfilled by Lazada? So they said, because products that are fulfilled by Lazada are delivered faster. And okay, so why do you care about products? Why do you want to increase the rank of products that are delivered faster? Right? I thought it makes sense. You want to help customers get their goods and their products faster, right? I asked them, why do you want products that are delivered faster? Because we get less complaints. So that was the key thing. Because it's delivered faster, their ops team gets less pressure from the complaints. So, and why are these complaints happening? These complaints are happening not because customers are not buying fulfilled by Lazada. These complaints are happening because our forecasting algorithm back then was underestimating a lot. So from this, you can see that the problem is the right way to solve this is not to change the ranking algorithm to increase the rank of products that are fulfilled by Lazada. But the right way to solve this is to improve our forecasting methodology.
Yeah.
So that's how I try to work with customers to understand if it can be solved. Sometimes the problem cannot be solved by machine learning.
Yeah.
So let me give you an example. What's an example? Okay, there was an example in the past where actually I can't think of a problem that cannot be solved by machine learning right now. Most problems I think can be solved by. Okay, let's say there's a problem in the past whereby I'm just gonna make up a fictional problem. And maybe actually can be solved by machine. In the past, maybe we had a lot of customers signing up for new accounts to get a new voucher, right? So every time you sign up for a new account, you get a new voucher account. So they said, hey, can we use machine learning to solve this problem? I was like, hey, for new customers and brand new accounts, we have absolutely no data on them at all. How are we able to solve this problem? And then I asked them, do you have any labels on this? Do you have any examples of new accounts that are actually fraudulent new accounts? And they don't have that. So in this case, we don't have data on these new accounts and we don't have labels of what fraudulent such fraudulent accounts are. So we are not able to solve it via machine learning.
Yeah.
On the other hand, you can solve this very easily via very simple ways, such as device ID. For example, the same device ID, if used to create 2 or 3 or more than one account, should not be given the new sign up voucher. So this is a problem that is easily solved by non-machine learning approaches, maybe just rule-based using device ID, and machine learning approaches, because you don't have the data, don't have the labels, is very difficult.
Yeah.
So that's how I would work with stakeholders to sort of distill and frame the problem better, and define the problems more suited for machine learning. But there are times where it's not the stakeholders coming to you with the problems, it's us going to stakeholders to get sponsorship for something we want to solve. For example, in the past, in Lazada, it would be trying to do something with the images that we have because we were not using it. Right now in Amazon, it would be trying to develop our first real-time recommender that can be contextualized. So let me give you an example of how I tried to do this in Lazada, and maybe we can try to draw some lessons from it. So I think back then in Lazada, we had a lot of product images, but we were not using it. So I went to my boss. He's a great guy. He's really encouraging of his team. I said, hey, John, we should try to do something about images. I can do some product classification or etc. and improve our classification models. He's a really nice guy. He said, Eugene, I'm pretty sure. I think that we might not be ready for it yet. I think our team doesn't have the capabilities. I was undeterred, so I spent the next 3-4 months on weekends learning about image classification, computer vision, and transfer learning. Transfer learning was a great thing, big thing that back there. So I learned a lot of transfer learning. I did transfer learning on ResNet and VGG, and very quickly I was able to train a pretty decent image classification model. But that was not quite sexy enough. And along the way, I learned that, hey, I could take this image classification model, take the embeddings, and try to build image search. Okay, so at that point in time, I was convinced, okay, image search is sexy enough to get people to want to do this. But I was not quite done. I had to build a UI, right? I had to build a UI where people could upload their own images, find similar images. It had to be fairly responsive. So at the point in time, that was when I first picked up Flask, learned some HTML and CSS, built some nice prototype. So once that was done, after 3-4 months, I was ready. I took my laptop, I went to show my boss. I was like, hey, John, I built this pretty cool thing. You can upload image of a dress and I can find you similar dresses. And he was like, holy crap, why didn't you tell me you're doing this? I said, I told you that I wanted to do this. You didn't think I could do it. I said, yeah. Then he was really excited about it. He brought me to demo that to the business, and the business was really excited about it because fashion, furniture, those are really big aspects of our business. And image search or image recommendation, and fashion is very aesthetic based, right? You want things that look similar. So that was a very big reason, big feature for the business to get excited about it. So they were excited about it, and that's how they agreed, hey, you should do this. And I really wanted to do this because I wanted to help my team get GPU capabilities. At that point in time, we didn't have GPU, and the only way to solve image classification problems or image search problems properly was with GPU. So that's how we got it. So I think, how would you pitch it? That is a story. That's an anecdote. I think there are 2 key principles. I think the way to pitch it is to not start from, hey, we're going to use this latest and greatest technology. We're going to use GPU, or we're going to use TensorFlow, or we're going to use this latest and greatest image classification model, because most people wouldn't understand that, and the business wouldn't really care about that, truth be told. But the way to approach it is to go with it from starting from the customer. What would the customer want, and how can we help them? How can we solve it for them? And usually, if you're solving problems for a customer, you are providing them with new features, the business tends to benefit as well. So I saw it as, I want to build this image classification so people can find clothes easier, or find toys or furniture easier. The business saw it as, hey, if we have this image search or image recommendation, we'll improve conversion. So that is a win-win. So approaching the business. I think the second thing that makes a big difference, and I made a mistake on this before, is to build a UI. So previous, and maybe we can talk about that later, but once you have a UI, once it's very responsive, it's on their fingertips and the business can play with it, they just get very excited. It feels real, right? Even though the prototype is just it runs on a single machine, it's not scalable at all. But once you let them play with it, it just feels real. As compared to, here's the chart of our image classification accuracy metrics, here's the graph of the learning curve, here's what we can do in a slide or in the document. It just doesn't feel real to them. But once you have a UI, it just feels, oh my goodness, it is so real. I want this on the website right now. It won't be right now. It will take maybe 3 to 6 months, but at least you get them to commit that let's do this.
Yeah.
So two main things. Get them really excited about it and allow them to interact with it, which helps them get really excited about it.
Yeah, I really love the story. I have similar experience when our stakeholders don't believe in the capacity of machine learning, and we have to quickly build a proof of concept type of model. I think it's very important to show them something tangible that they can play with. So, exactly like you mentioned, if I just tell them, hey, I built this machine learning model, 99% accuracy, they still don't really have an intuition of what is the value you're going to bring to the business. But to build this prototype, you don't need to have a very high, accuracy or other performance metric. Maybe you have 70 or 80% confidence, but you make it into a product from a machine learning model to something people can interact with. I think that's very important. And I think that going back to a blog post you wrote, you said a data scientist or machine learning scientist should be more end-to-end. And I think your story about, building API is very inspiring. So can you talk about why you think machine learning scientists or data scientists should be more end-to-end?
Sure. I think the reason I wrote that post was that I think I saw a Reddit thread that had, almost 10 different data science roles. There's like the product data scientist who's doing the analytics. There's the machine learning scientist who's doing the machine learning. There's the machine learning engineer. There's the data engineer. There's the data PM. There's the AI architect. and I was really confused. I was like, how would this team work? Anytime you want to build a product, how many people would you need in a room? And anytime, let's assume that I'm an applied scientist, I want more features, I want more data features, I would have to talk to a data engineer. How long would that take? So I think that it really fragments everything. And I felt that it firstly, you reduce the context. For example, me as a data scientist, and I've seen teams that are like this, where the data scientist is not allowed to actually do data engineering or even do the feature engineering. Yeah. So if you're not allowed to look at the data itself, how do you know what data can be useful for customers, for your machine learning model? If you don't know or are not able to explore the data, how will you know what trends are useful or to create features, or whether it will work or not? So I think that's one thing. And without the context, so that's one thing where you don't have the context of the upstream, you don't have context of the data. Then there's the machine learning engineer. Imagine I'm building a model, I'm passing it to the machine learning engineer, and maybe the machine learning engineer has certain constraints. He might have a constraint that, your model has to respond in 40 milliseconds. And if you're not aware of this, you would build a big ass transformer BERT model that takes, I don't know, a second to respond. You don't know how to scale it. How would he put it into production? That would never be used. I think this context is really important if you really want to build useful products that gets used by the business and that really impacts customer lives. And like I mentioned, I think, let's say we put something in production, there's a bug right now, and we need to triage it. I would need a product scientist who understands the dashboards. I need a data engineer who understands the data pipelines. I'll need the ML engineer who knows the alarms, who probably is the on-call, and I'll need the data scientist or machine learning scientist who's actually building the model.
Yeah.
I'll need all these people in there, and it's so difficult to coordinate schedules, and how to triage it and debug it. It's just a headache. And I also think that the main thing, I think why data scientists should be more end-to-end, I think it's really a concept of ownership and accountability. Far too often, I've seen it that so when I was talking with my peers who are also leaders in other teams, I've seen this approach whereby They break it up with nice interfaces. The data engineer passes the data to the data scientist via the data warehouse interface, and the data scientist passes the model to the ML engineer via some kind of interface. It could be just an R model or R script, and the ML engineer has to convert it into Java or whatever, C++. And that just doesn't work, right? There's so much that's lost in translation, and I'm aware of cases whereby the model doesn't work in production, and then things get passed around. Who is responsible for it? Was it an issue? Is it an issue with the data drift, where the data engineer, would the offline data and the online data doesn't match? Is it an issue with the machine learning model? And the machine learning aspect, whereby when you're doing your train validation split, you do it properly, does it reflect production? Or is it a problem, an issue on the machine learning engineer side, where the code doesn't translate it properly, and it just gets passed back and forth, and I just don't like that. I think that that's an impossible way to work. So I think a lot of people read that post and they kind of misunderstand that I want all data scientists to be full stack, whereby you can do everything end to end. That's not intent. I want data scientists to have more ownership, not to have more ownership to own the project, but to have more ownership in the sense that they are responsible for everything end to end, from the start of the problem, the start of the project, to after it's delivered. And even when something happens when it's delivered, they should feel that they have responsibility, and it's not, I handed it off to someone, it's someone else's problem right now. So that's why I think it should be end to end.
Yeah, I think it's very important to differentiate ownership from doing everything on your own, right? Because exactly like you said, I also read a blog post from Chip Win. She said data scientists shouldn't do Kubernetes. I don't think that's an absolute that was her purpose. I think what she meant was a lot of data scientists get into data science because they're passionate about finding patterns in the data, driving insights, and they're not so passionate about the engineering part, and you don't have to do that. But I think it's also very important to remember to take ownership of the entire pipeline. If the model you developed, you're passionate about, fail in the production, you don't have to be the person to fix it, but you need to go talk to the engineers, to brainstorm with them, be in the meeting, and make sure you put on a product management or program management hat to make sure the model you spend a lot of time to build on will actually be delivered and drive business value.
Yeah, I fully agree on that. I think if you think about it, the time spent to build a machine learning model or build a machine learning system is very little compared to the time spent to maintain and operate it for the next couple of years. And that's when the effort is really really comes in. And if people take more ownership, data scientists take more ownership, that effort can be greatly reduced.
Yeah, that's a great point. So you mentioned design, building, operating machine learning system is a big effort. So who exactly do you usually collaborate with, and how do you scale yourself?
Usually I collaborate with the downstream folks. That would be product designers, product managers, and engineers. So product managers would really they would share, here's maybe we're going to create a widget, let's just say a random widget, or review some, we're going to show reviews whether they're fraud or not. Product managers might say that, hey, for this widget, we're going to show the number of stars the item has, the price, etc. And they might say, hey, we don't want two products that are too similar to be each other, because they want some kind of diversity in that. So okay, you would take in this considerations and you try to build it. Because let's say if you were trying to build a recommender and someone goes to find Harry Potter, and the most relevant book would be Harry Potter series 1 to 7 and 8, or but that wouldn't meet their intent of diversity, right? So you might want to layer it in. And engineers, I work with engineers a lot, because as much as I would like to do it all myself, setting our infra with AWS CDK or setting up alarms, I would take 5 to 10 times the amount of time that a decent engineer would take. So I work with them to try to get them to do the stuff that I'm bad at, such as setting up infra, or maybe systems that involve Java that I'm just not as I'm just not as effective or efficient with them. So mostly working with these two bunches of people.
Mm-hmm. So previously we talked about working with stakeholders, asking the right questions, and now you're actually building a model that someone at the other side of the UI would use it. But usually data science are several steps away from the users relative to product and UI. So how do you maintain empathy with your end users?
So I realized that in my career, I work in a very specific field of data science. Specifically, I work in B2C data science, whereby I'm not a consultant, except for a short stint in IBM. I'm not a consultant. I don't build things for enterprises. I mostly build systems, machine learning systems for users, and I really enjoy that. So a big because it makes it feel really meaningful, and I feel there's a lot of impact. One big benefit of this is I get to dog food my own product. So if I'm building recommendation systems, right now, I tend to browse and search for books a lot on Amazon, and I get to see, hey, this recommendations, it's very personalized, it doesn't consider context, or this context is, it considers the context, but doesn't take into account my personal interests, or maybe things like, this book is has very low reviews, why is it showing up, etc. So that is one thing. Also, in my previous roles and even now in Amazon, we do a lot of user studies. So user studies would be, they could be quantitative, like we send out surveys, get a few hundred people to respond. Or it could be very qualitative, where someone trained, a UX researcher is there interviewing them. And we also do some really interesting stuff, like maybe we develop a prototype of our widget or of our app, maybe an app redesign, and we get users to try to use it for the first time while they are videoing themselves, and we get to see their real expressions. Of course, this is really expensive. We don't do too many of this, but it really gives you a sense of which features spark joy and which features confuse users. So that's one way of using it as well. And of course, I look at it through the data, right? I think so let's say we're trying to figure out maybe, okay, do users read a book completely? How many users stop reading a book? Which books are popular, right? So, being from Kindle, I actually know reading behavior, and I know maybe if a user gives out a book halfway, maybe they're not that interested in it, as opposed to they finishing it. And of course, maybe in other aspects, maybe, for example, let's say on a phone detail page, maybe let's say in a previous role on the phone detail page, the question was, on an iPhone detail page, should we recommend other phones or should we recommend accessories? Well, we can actually look at this from the data. When people browse for phones, do they browse other phones or browse other accessories at what rate, and what actually leads to more purchases? And based on that, we can actually learn about what users need when you're browsing for an iPhone. Do they actually want comparisons or do they want accessories? So that's useful.
Okay. And so now you understand the users. When we think about launching the product in production, how do you iterate machine learning projects?
I take a time box approach. I'm quite a fan of Agile and Scrum. So I take a time box approach where I try to imagine, hey, what do I estimate this to take? And I try to halve the amount of time I need. So the iterative approach, actually, there's three main steps. So the first step is a feasibility analysis. So let's say someone comes to me with a problem. Maybe the problem, I don't know, just take any generic problem. I'll say, okay, let's define the problem, define the metrics, define the constraints. And I will go back and I will look at it at the data. Do we have the data to solve this? So let's take the previous example. Are you able to identify voucher fraud from first-time users? In that case, I don't have the data. Maybe after a week of trying to find it, I would tell them, hey, we actually don't have the data to be able to solve this problem. And then we'll stop. And we, at that point in time, we would just cut our losses and say, this problem can be solved. Maybe we can try to start collecting data now and go back to it. But if at a feasibility analysis, we decide that, hey, we do have this data, I would have a check-in with the stakeholders again. Okay, I've identified that we do have this data, we do have these labels that sort of are a proxy for whatever business objective you're trying to achieve. Then if everything goes well, we agree, and I move on to the proof of concept stage. So this feasibility analysis stage takes about any time between 2 to 4 weeks. And then the proof of concept stage, I would try to use the data we have with a proper train validation split to try to solve the problem. So let's say the stakeholder wants to have this solved at an accuracy of 95%. And let's say I'm only able to solve it to an accuracy of 85%. Maybe every 2 weeks, I'll check in with them. 85%, is it usable in production? If sometimes it might be, just put it in production first and we try to improve on it. Sometimes I could get, hey, my accuracy is only 65% and it's way too far, and there's no way I would ever close the gap with the existing data. So that way, at the proof of concept stage, maybe it usually takes about 2 or 3 months. At the proof of concept stage, we would just say, I don't think this is solvable with the data to the level of performance that you require, and we might just call it off. And that's okay, right? Because after feasibility analysis, which takes about a month at most, after proof of concept, it takes about 2 months, we've only spent 3 months on it. And we learned something. We learned that we don't have the right data to be able to solve it at a performance metric that we need. We tried it, let's move on. But of course, if the proof of concept works out well, maybe they wanted 95% accuracy, we got 91, 92 is good enough. We then move on to production, right? Which probably takes about anywhere between 3 to 6 months. Hardening the code, putting the code in production with proper testing, validation, setting up the infra, etc. So this is the iterative approach. At any point in time, after feasibility analysis or after the POC, we can always call off the project and say that we're just not able to solve this with machine learning right now, or solve this with the data we have right now, and that's okay. Right. Yeah. So that's how I would try to iterate a problem from baby steps, from the basics, from the data to the machine learning and then to production.
Yeah. Thanks for sharing that. Now, how do you measure the impact of your project? And can you share some project that had a great impact?
Yeah, I think this really depends on the definition of impact.
Yeah.
I think for the business, the definition of impact would be dollars, right? Like maybe it would be conversion, or number of items you sold, or number of additional revenue from your widget. So that's one. For me personally, my definition of impact is how I help customers or sellers. So let me give you an example. In my previous role, I was working on ranking products on our website, and it was pretty successful. I mean, I had a roadmap. I want to improve the ranking algorithm, and then yada yada yada. So I built something that improved the ranking algorithm. We improved conversion and revenue significantly. I think like by 5 to 10 or 15%. But that was the first item on the roadmap, right? To give something to a business. But then the next 2 items on the roadmap were the things that I was really interested in, which is the next item was how would I introduce new products to customers. So new products would be things like sometimes new brands get on board to our website, or new sellers come on. And in e-commerce, there's a long-term effect, which is something like 20% of sellers account for 80% of sales. So the small sellers can't really grow. So what I wanted to do was to introduce new products in a smart way that doesn't affect conversion too much. And I did that. I mean, our team found a very smart way to do that, and it was very good. We improved the engagement on new products and new sellers by 5x. That's 500%. So you can think about it. We are giving these new sellers traffic to help them grow. And then the next one, and we didn't reduce conversion at all. And then the next one was improving the quality of the product. So improving the quality of the product would be things like DAO ranking, very popular product, but is very high, very low rating, or has very high return rate. So imagine if you are a new customer on our platform, you look for a dress, and this dress is ranked right number 1, and it's very popular, a lot of ratings, but it's bad dress. We know the seller actually delivers something of very poor quality, not like the images. And you get it, and you would never come back to our platform again, right? You're just so disappointed by the experience. I want to prevent that from happening. So what I did was I proposed that I'm gonna actively downrank poor quality products based on what we know, based on statistics like high return rate, low ratings, high complaints, or fraudulent. There's a mismatch between what they show on the website and what what the customer gets. So we downrank that, and we halved again. We cut return rate by half.
Oh wow.
That is, if you ask me, that is amazing. It means we have reduced the number of unsatisfied customers by half.
Yeah.
So that to me was very fulfilling, and we made a post. They made a poster of that, and today I still have that poster. So what I found was that what is really impactful for me is helping people. So for example, I mean, we increase conversion and revenue by, I don't know, tens, 20s, millions. I don't know how many millions. But that I didn't get as much of a high from that, from helping sellers grow and from helping customers reduce their return rate. So I would say impact really differs from person to person.
Yeah. So now after you have shipped to your machine learning project and you made impact, if you want to keep it in the production, how does you and your team operate and maintain the model?
There are a few things to think about. I think the first thing, the most basic thing is to have your monitoring and alarms. So if you think about it this way, you have a model in production and all of a sudden the website is not calling the API correctly and all the calls are erroring out. If you don't have a monitor on the percentage of alarms, it would never actually be seen by customers and you would never actually know. So it's important to have these alarms on, the error rate, the latency, and the throughput. For example, all of a sudden maybe they stop calling your API for some reason and your throughput falls down to 0 or the 1s or 10s. You know something is wrong. So that's something you should monitor at a latency level, and you should have alarms and you should get notified if any of those metrics don't look good. And then in terms of data, I think it's essential to make sure that your data pipelines are robust. I think for some more mature companies where the data pipelines are pretty good, it's not that big of a problem. In the past, where I was in a healthcare startup, we were getting data from healthcare providers. And what we didn't know but eventually realized is that they were giving us periodic data, dumps of this data. But these periodic dumps were actually handmade. In the sense, they were writing the SQL query from scratch every single time. And the columns, the data schemas would change. And, of course, that would break our models.
Yeah.
So what we had to do was we had a pre-check, which is, checking the columns of the data to make sure the columns of the data match. And sometimes standards change. For example, I work in healthcare. We have something called the International Classification of Diseases. And that changes. We have, I don't know, at a point in time, we were at ICD 9, 10. I know there was 11, maybe 12 is out. So standards change. So you also have to be aware of that. So anytime these standards change, anytime they upgrade to a new classification of diseases, all your categorical values would change. That's when you would have to retrain your model, and all your one-hot encoders or all your categorical encoding would have to change as well. So that's the data. And for machine learning model, I think a very straightforward way to make sure that your machine learning model works well in production is to have a small slice of the most recent data. And after you train your model, just evaluate your model on that small slice of data. And you will just set some threshold. So on yesterday's data, is the accuracy still above 95%? If it is, just deploy it to production. If it's not, just break the whatever orchestrator you're using, maybe Airflow pipeline or something, and it will just error there and send you an email. I think it's better to have a stale model in production, maybe 1 or 2 weeks old, than to have a incorrect model in production that's just going haywire.
Yeah, thanks for sharing that. I'm curious, what are some failures you had in your machine learning projects, and what did you learn from those?
I think the one thing that I can share is, maybe it's not a failure. I don't know, actually. It's a good learning. So there was once I actually built and deployed a product classification model. So this was at Lazada, right, where they hired me to do product classification on titles. I was so excited. I built and deployed it on a prototype server, and then we had a newsletter then, so I shared it in our newsletter. And I was saying, hey, if you want to use this model, just use this curl command. So curl is something that you need to type in a command line. So what I didn't realize was that, actually I probably did, I just didn't really care about it, is that our business users, the people that really mattered, the people who I really wanted to try this model, they were on Windows machines and didn't have curl. And I mean, it was just so difficult for them to, you know, figure out how to get curl working, to try this product classification model, to change their product title, that no one bothered. So after I sent out that newsletter, I was so excited. I was just waiting there looking at my prototype server, right? Because I have logs of every time that a new request come in. Crickets. There was nothing for 2 hours. So I realized that, okay, I need to put an interface on this. So that was when I went back. I learned a bit of Flask, HTML and CSS, built a nice UI for it, where you could just type the product title, you press enter, and, you know, top 10 or top 5 product classifications come out. And the next newsletter I sent it out, and again I was waiting at my server. This time my tiny Flask server actually crashed.
Wow.
Because there was so much traffic, and it was at the point in time I learned that the customer is really important, and the internal business stakeholders are really important. You cannot expect the customer to be typing a curl command. You have to provide them with nice interface, and if you do that, they will use it and they will provide you with so much feedback. So that was a big mistake I learned, very embarrassing, and from that I learned a very valuable lesson.
Yeah, I think that's a great lesson. So if you really want people to try your machine learning prototype, learn something about building API, Flask. Yeah, I love that. And in your blogs, I also read you talk about it's very important to writing tests in machine learning project development phase, but it hasn't really been emphasized a lot. Can you share more about that?
This is something that came about in my time in healthcare. So for example, let's say we are going to predict the propensity of, I'm just going to take I think it actually happens as well in males, but I'm just going to take an example. Let's say we're going to predict the propensity of breast cancer, right, in males and females. So in females, the probability would be non-zero. In males, yes, even though males can get breast cancer as well, let's assume that males should not get breast cancer. So let's say someone changes the categorical variable to males. Let's say we have the exact profile, but we just change the gender from female to male. And all of a sudden, the propensity to get breast cancer goes up. How would the user feel? It just feels like, oh, I cannot trust this model. Let's take another example, propensity for lung cancer, right? And let's take the exact same profile, exact same person, but we change it from smoker to non-smoker.
Yeah.
Should the propensity for lung cancer go up? No, it should drop, right? Because it's not a smoker.
Yeah.
So these are some of the behavioral tests that users expect from your model. And, you know, the standard software engineering unit test we do for this doesn't really cover this.
No.
So I think it's really helpful to create these behavioral tests. So creating these behavioral tests can be quite taxing. You're going to need some business domain knowledge. But as you come across these complaints, you know, this didn't work very well, you start to understand that the business domain knowledge would be that, hey, you know, generally people who are older would have higher rates of cardiac arrest. And, you know, if someone is given the same profile, increase in age shouldn't lead to a lower propensity of cardiac arrest. Or generally, people who smoke should have higher propensity for, I don't know, diabetes, lung cancer, etc. So you can start to encode this, and you can start to test if your model behaves this way before releasing it in production. So you want to make sure that your model learns the right thing. And why is this very important? Because if you make enough of these mistakes in production, you really start to lose trust in the customer, right? And then that's when it gets really difficult.
Yeah, I think that's very important, because sometimes when we build a machine learning model, we just focusing on the metrics. We forget about the domain knowledge. And I think now people start to talk more about causal inference in machine learning. Did you just get lucky, or your model actually, you know, there are some relationship within those variables? So I think it's to your point, the, you know, smoker, non-smoker, maybe you need to have some Bayesian rule, some element in your model to think about what exactly going on in your model instead of just treating it as a black box.
Yeah, I fully agree. And I think I got inspired by this testing. I think I read this paper. It was an NLP paper whereby, I can't remember the exact name, whereby, they just took sentences and they just changed some of the sentences in synonyms. And they tried to predict the sentiment. Did the sentiment change because it was just a change in synonym? Or they tried to predict changes in the model's behavior, classification of the sentence, classification of occupation by changing it male and female. With a difference in gender, does the occupation predict the change? And it does. And so that's where I got the idea of behavioral testing. But I thought to apply it in my world, which is mostly tabular data, at least at that point in time. In healthcare. So I think it's useful to have this. I mean, you won't be able to catch all of it, but it's always useful to have a good test harness so that you're aware of what you're feeling and what you're doing well on.
Yeah. And previously you have a lot of experience working in startups, and now you work at Amazon. So what's the difference between startup and working for a big company?
I think Amazon is slightly different. You can think of Amazon as a group of startups, right? So even within a team, it's still very startup-ish. I think there are a few key differences though. I think in Amazon, the infra is really nicely set up. So in my first week at Amazon, we have a Jupyter Notebook-like interface, and we have a very nice data warehouse and a very nice data catalog. Within my first week at Amazon, I could access all the data I needed. I was able to plot a graph of the rate at which user reading completion rates within the first week. I had access to the data. I was able to do it in a Jupyter Notebook interface. I was able to spin up my own cluster to crunch that data. So that was really nice. In a startup, you probably don't have this. I recall in my previous startups, in order to crunch data in Spark, it was still mostly Spark Summit. We don't have a nice Jupyter Notebook interface, that could help us spin up a cluster and do all the plotting. So that's one thing. On the flip side though, is that, and maybe I'll just give you an example. On the flip side though, is that startups run out of money. So yeah, big companies can run out of money too, but more so for startups. So previously I was in a startup and I was in the know. I was aware of the amount of cash balances that we have. And it was not much, and we will always be running out of money. And with this startup with this pressure in mind, sometimes you might not be so inclined to take big bets on innovation, right? You would be, okay, a 1-year bet is too long. Can you make it a 2-month bet or a 3-month bet? So that could be one thing. So pros and cons, I think that mindset, that mentality is really good for the customers. You really test and iterate very quickly. I'm a fan of the book, The Lean Startup. I really practice that in my work. So I really like that mentality. I like that when everyone has that same mentality, we iterate and we push very fast for customers. On the other hand, in big companies, the infra is all set up. You have more breathing room to do a bit more research and innovation to serve customers and take more bolder big bets. So I think that's one key difference.
And previously we talked about roles, right? Should we be more specialized or should we learn everything a little bit? So if someone says, I want to really build a machine learning solution from the beginning to the very end. I want to build an API. I want to do Kubernetes. Or there might be someone else says, I just want to, do my research work and create a prototype, and someone else take it over to production. So for those two type of people, what type of organization, size of the company do you suggest them to join?
Firstly, we need both types of people. We do need people who really focus on the research and the techniques to really push it forward. But we also need generalists who are able to get it done end to end to put it in the production so customers can benefit from it. I would say that in general, it is the bigger companies which have innovation labs and the budget for research that allow more of the specialists to conduct their research. But that said, there are also some very well-funded startups who maybe not startups anymore, like OpenAI, Hugging Face, that also I believe have room for such innovation.
Mm-hmm.
On the other hand, if you want to be a generalist, and if you really want that opportunity, I think there's no better place than a startup.
Yeah.
In the sense that you are forced to do it, to do everything end to end, because there's really no one else to help you. Whereas in a bigger company, you might not be allowed to do everything end to end. There might be a clear separation of responsibilities. I know of data scientists who are not allowed to write production code. I also know of data scientists who are not allowed to do their own feature engineering or write data pipelines, because there's the stereotype, the incorrect perception that data scientists can write production code, or they don't know how to write efficient data pipelines and orchestrate them, and they just consume too much of the cluster. So if you want to be a generalist and do everything end to end, I think a smaller startup-ish company or even a startup-like team in a big company would be more suitable for you.
Mm-hmm. Yeah, thanks for sharing that. So when we talked about your day-to-day, you mentioned in the beginning of the project, you talk to stakeholders and then you write documents. I feel like this is a very important thing in our daily work, but it's kind of like an undervalued skill. Can you share more about why writing documents are important for machine learning projects?
Yeah, I think as part of that, I also want to share why I started writing these documents, right? I think 5 or 6 years ago, I was at a phase whereby I was interviewing data scientists who were 2 or 3 steps ahead of me, like lead data scientists, chief data scientist, CTO even. I was asking them, hey, I guess the main question I was asking them, hey, what does it take to be an effective data scientist?
Yeah.
Think of the rock star data scientists you know of. What can they do very well? I asked them, hey, are they PhDs? Can they conduct very good research? Are they able to write good code? Or are they able to write good pipelines? Or do they really understand business? I think generally the majority of them said that, hey, those are really good skills that you mentioned, but the most effective data scientist, the one that I cannot do without, and the one that's really scarce, is the people who can communicate. I was really surprised because I thought, hey, everyone can talk, everyone can write.
Yeah.
What is the big deal about communication? But so many of them said that I decided to just try it. So I decided to just start writing once a month, right on my blog. I decided to speak at meetups. And that made a big difference. I realized, oh my goodness, so many people can speak. Okay, so the feedback I got was that my boss got was that, hey, I just had a meeting with this data scientist, another data scientist, and I didn't understand what they were talking about. Or I just got a report and I don't understand what it means. Then I realized, communication, everyone can talk, everyone can speak, but not very many people can do it in a way that the other party can understand.
Yeah.
So I thought that's very important. So that's why I think writing is important. So the question is, why is writing documents important for machine learning projects? I think it is important for machine learning projects for the same reason that it's important for all projects.
Yeah.
So let's just imagine before you try to do a project, or you have some vague idea of something in your head. It's very vague. It's just in your mind. You haven't really defined it. But when you try to write it down on paper, I don't know about you, but for me, it's always very, very difficult.
Yeah.
It's so difficult to write it down. And I was talking to Alexei, a mutual friend. He says he thinks it's so easy, but to write down a sentence or even a paragraph takes half an hour. And I have the same thing. And what I realize and what I read from a lot of people is that because when it's in your head, it's very fuzzy.
Right.
It's not clear. You don't have a very detailed point of view. But when you have to write it down, you force yourself to very specific. Or how much is it going to cost? How many man days are you going to take? What infra are you going to need? Because if it's in your head, I'm going to deploy this, I'm going to scale this, it's going to be auto-scaling.
Yeah.
I mean, when you write it down, you have to write the details on a design doc. You realize that you have to work out all these details. And that's really important. And the thing is, even after you've written the design doc and it gets lost or no one reads it, that's okay. Because you've already done all the thinking, all the research in your mind. And if you think about machine learning, right, only decently sized technical project, it's going to be more than a one-person effort. Usually it's across multiple teams, multiple functions, with product, with business, with engineering. If it's just all in your head, how are you going to share it with them and get their feedback? And some people do PowerPoint slides, just bullet points. Oh, we're going to do this with auto scaling and whatever. But how is that going to scale? You're going to need to give, 3 or 4 presentations, and maybe they can record and view it. But nothing beats a solid document, and that's what I learned from Amazon's document culture, and I really love it. I cannot do without it right now. And I think one thing that is really important that I found really useful, and I imposed on my team in the past, is that before they start a project, is to write a one-pager. And the one-pager is very basic. What is the intent? What is the problem we're trying to solve? What is the deliverable? What will we deliver? What is the success metrics? And what are the constraints? So we write that down in the document. And sometimes, if the project gets long, it stretches out 6 months, 9 months, and you get a bunch of feedback and new feature requests every now and then, people forget what the original intent is, and you get lost. But if you write it down in a document, at any point in time, you can always refer to it. It is your map. And that just gives you and it has happened to me before. I've worked on long projects, or after long hours, or after so many changes, I forget, what am I supposed to do? Oh, there's this new there's this new fancy technique. Let's use this. There's this new data. Let's use this. But when I forget and I refer to my original one-pager, I'm like, oh, this is the original intent. This is the success metric. I do not need to use this. I don't need to do that. That feature is not required. This update is necessary. I find it very useful for me to guide me forward. So I tend to have a one-pager to summarize the intent of this. So I think that's very important for machine learning projects and most technical projects in general.
Right. So writing is not about finding beautiful words. Writing basically is thinking clearly.
I fully agree. I think that one thing that data scientists are guilty of is that they know how to use the right words in terms of academia. Like they would say, oh, the presentation is this, the KL divergence, or the backpropagation, or whatever. But business people don't understand this.
Yeah.
Oh, we're going to put it in an embedding space, and we're going to try to vectorize it, and we're going to try and find the nearest neighbors. But you need to write it in a way that people can understand. What it means is that we're just going to change this image to a set of numbers, and because numbers have distance, we're going to find the nearest numbers, and based on that we can find the nearest looking images, and that is the way that they can understand. And when they understand something, it makes it easier for them to trust it. If they completely don't understand something, if it's just a black box, how would they trust it? How would they use it? How would they push it to users, to customers, and have them try it? So I think writing is very important by simplifying it, making it clear for other people to understand.
Yeah, exactly. And writing or communicating is not about just telling people what you know. It's about thinking about, one, who is your audience? And two, how can you speak their language? When you talk about precision and recall, those are great if you speak to a technical audience, but you speak to the business, translate them into a business use case. This is what happens when we have recall of 90%. Give them a little story, an example, so that's easier for them to grasp.
Yeah, I think I fully agree. I think it really depends on your audience. I think in my work, I mostly speak to two audiences. One is the business stakeholders. So for them, I try to make sure that I don't use our scientific jargon. And the next one is fellow scientists. And in those cases, using scientific jargon can be useful because it eliminates a lot of the context. We know that this word means this thing, and it just makes communication efficient.
Yeah. Thanks for sharing that. So when you talk to stakeholders in the beginning of the project, how do you ask the right questions?
I think that's a good question. I'm asking the right question. I think, again, it's just this mindset that I have is, okay, they've given me a problem. How can I cut the problem in half? And again, it just goes back to me being very lazy, trying to solve the problem in as little time as possible, because we always have too many problems. So let me give you an example. Again, I'll try to draw some principles from it. There was once when a stakeholder came to us and said that, hey, we have a problem with product reviews. Right now it's still manually classified. Can we automate it? Okay, can we automate it? So that's just that's a very big fuzzy problem, right? Automate it. Okay, so I started to break it down. Okay, automate it, and I try to see what's the minimum that I could get away with. Okay, automate it. What accuracy do you need? Because at the start, everyone understands what accuracy is. Okay, I need 95% accuracy. Okay, 95% accuracy is a pretty high bar. So I asked them, okay, which one is more painful for you? Is it more painful if we let a fraudulent review show up on the website? Or is it more painful if a valid review is flagged as fraudulent and we lose that one review? Or is it certainly a fraudulent review showing on the website is more painful?
Yeah.
So if you consider fraudulent reviews as positive, for them, what is more painful is to have, it's not too bad to have false positives. It's not too bad to have valid reviews flagged as fraudulent. But what's more painful for them is for these fraudulent reviews to get away. These false negatives. So immediately I moved away from the recall or the accuracy metric into false negative, false positive. Okay, for false negative, what is the amount you can bear? 95%. For false negative, it was as low as 50%.
Yeah.
So that now I then zoomed in on false negatives. And false negatives, there are a lot of different false negatives. There's a lot of kinds of reviews that they want to flag. It could be that, hey, sometimes the review is a competitor seller posting a link off the website or even on the website to a different product. That's something that we don't want to encourage. It could be a customer, thinking that the review, they can provide their contact details. They want to make a complaint. They want to refund. They post their contact details in the review. Again, we don't want that. Or it could be just, spam reviewers, sellers posting reviews of their own website, of their own product. And that would just be spam. So I had to ask them which of these were more important to you. And again, I try to break down the problem smaller and smaller. So that's how I try to ask questions. I don't know if they are the right questions, but they are questions that help me reduce the scope of the problem and solve it in half the time. So I think there's two ways to think about this. There are a few principles that it can be useful. So I think one way is to really take on ownership end to end.
Yeah.
Imagine that you are your manager and your manager has multiple projects that you need to do, and you don't have unlimited time to solve this problem. Some data scientists I know, when they get a problem, they're so happy about it. They love to solve it to the best extent. They spend years on it. But we don't have that. Sometimes we don't have that luxury. So that's one thing. So if you have that mentality of, trying to reduce the amount of time, trying to be lazy, you will try to scope it down. Second thing is if you have that mentality whereby you feel the sense of ownership from the business, you try to solve the problem to the best extent for them. And sometimes some people might just take 95% accuracy, okay, and just run off and solve it. But if you try to put yourself in the shoes of the business from the stakeholder, what do they really need? And you ask these questions again and again, you get to drill down the problem, and what you build actually solve their problem.
Yeah, thanks for sharing that. And in my experience, sometimes stakeholders come to us and they want something with 100% accuracy, or something that machine learning isn't capable to provide. And with those type of requests, or some other things that you feel you cannot support, how do you communicate and push back?
So I think there's a few things here. So I think one thing is that, hey, if a stakeholder requires an exceptionally high level of performance that maybe our team or our data is not able to do, usually the problem I have is that I would never say no. Usually I would try a feasibility assessment on it. And that takes only 2 to 4 weeks. At least we put in effort to try to solve it. And maybe we'll solve it, and then we go back to them, hey, this really isn't solvable. We don't have the labels. We don't have the data to solve it. We tried, and we're just not able to do it. And sometimes they would accept it. So that's one problem where stakeholders, that's one issue where stakeholder comes to us with exceptionally high level of performance that we just cannot meet. But more often than not, the problem I face is with too many stakeholders coming to us with too many problems. And usually in the past, what I would typically do is I would just say yes and just overstretch myself. And I try to please everyone, and you actually please no one. But then this changed when I began to lead a team. I began to manage a team, and they were counting on me to turn away these problems, right? I couldn't just take on everything because the team was just overstretched. So how I would say no, how I would turn down this request is to ask them, okay, we are going to do this for you, but how would customers benefit? How would the business benefit? Surprisingly, a majority of the time, I would send them this email that's, okay, it's just a 2-sentence email. How would the business and customers benefit? A lot of times they just don't respond because they don't know. They haven't thought it through. They just want to do it because they're interested in it. So that's one early line of defense. That's easy. The second line of defense is pretty straightforward. So if they have a very well articulated business benefit, if they have a maybe like a PR FAQ, like in Amazon terms, okay, we have to do it. But sometimes the team is stretched. So what I would do back then as a manager was I'll pull up my Excel sheet roadmap. Look, these are the things that we want to achieve for you by the end of this year. And I know that this new thing is very high priority. How would you like me to shift the priorities? So I put the ownership on them, right? Because we are serving them.
Right.
And you have to decide how to prioritize your projects. Sometimes at a point in time, these other projects are very much more important. Let's just put this on the backlog. Or sometimes they would take something in the existing roadmap off the backlog, off the roadmap and put a new thing in. And that's very important in the sense that it allows my team not to overstretch ourselves. We serve our customers with our limited resources and time.
Yeah, I think that's very important. If you have to say no to a request, provide evidence. It's not like I don't want to help you. There's something else that's more important to you at this point. So going back to your career, in your journey getting into machine learning, and also as you grow your career, what are some factors that are important to your success?
I would say that the number one most important factor of my success is luck. Back then I was coming from a government. I was an investment analyst. I knew a bit of SQL, knew a bit of R. I mean, why did IBM hire me as a data scientist? Maybe the only reason I could think of is because I was lucky. Okay, maybe there was some preparation involved. I learned a bit of SQL on my own. I knew R and statistics from my undergraduate degree. I knew a bit of machine learning. I was interested in it. I dressed up well for an interview. I think I spoke well, and they hired me. So at a point in time, they hired 20 people, and I was the only non-technical people. The rest of the people were all engineering or information systems or PhDs in biochemical or whatever. There was also one other econs person. So why they hired me? I can't think it's luck. And then the other thing was that so from IBM to Lazada, how did I do that? I think again, it's luck, right? I mean, I did a Kaggle competition. We did well. I just gave a presentation. Luckily, there was a startup who had the same problem, and someone was there to watch a presentation, and then they invited me in. Again, that I think that's luck. Okay, maybe if I had not done that meetup, if I had not taken the effort to do that meetup, that would never have happened.
Yeah.
But how do you know? I mean, I've done. Yeah. I mean, how do you know that would happen? So maybe it's. I think Naval calls this hustle luck. You hustle enough, sometimes luck comes and find you. Maybe that's that. And then of course, getting hired in Amazon. I mean, I'll share that I received multiple offers. One of the offers was from Zillow, was from the iBuying department. At that point in time, my wife was like, "Hey, you're gonna really love Zillow." I mean, she's in real, she really likes she's in Airbnb, so she likes this. And I was really thinking very hard between Zillow and Amazon, but I was really drawn to the mission of the team in books and leadership principles. So, and I took this offer. So I think again, I attribute it to luck that I dodged the bullet of Zillow. Well, not really a bullet. I think Zillow is really awesome, but I can probably imagine that if now they are letting go 25% of their workforce, I can imagine if I joined that team, I would be part of that. So I think luck and maybe just doing a lot of things.
Yeah. I think everyone, there's some luck in our career, and including myself. But I think by putting yourself out there, you're attracting a lot of luck. For example, you go to the meetup, you did a hackathon. If you never have done that, maybe there would be someone else getting lucky in that event. And also, if you don't write your blogs, there won't be a lot of other speaking opportunities for you, and we wouldn't met. So maybe I can also share how we met. I don't think you know this part.
I was just thinking about this, but I was like thinking, oh no, what if Daliana asked me how we met? I can't remember. I can't remember if I reached out to her or she reached out to me, or how did it happen.
Yeah. So I posted something on LinkedIn, I don't remember today. And then I saw someone commented, and it was you, and you said something like, oh, I also wrote about this blog. So in the beginning, when I see this comment, I was like, who this guy? I don't like you. Why you promote your article under my post?
Sorry.
And then I was curious. I clicked into the blog. I was like, okay, this actually has a great point. It's a great blog. And then I look at your LinkedIn profile. So then I was like, oh, I want to meet Eugene. And then he also works at Amazon. So I send you an email, and then I suggest we can do a virtual coffee chat. So that's how we met. And if Eugene doesn't have the blog, if he doesn't promote his blog, I would never met him. So the lesson is, if you have good good products, you have good blog, if you really believe in yourself, promote it, market it. Otherwise, people won't be able to see it. And it doesn't matter how good your model, how good your blog is. If you don't find a way to distribute it, and people won't be able to learn from you. So it's not about marketing yourself. If you really have something to share to the world, it's about having a way to help more people. Think about it that way. That will help you to feel more comfortable to share your content.
Yeah, I fully agree. I think the reason why I posted on, I really can't remember, but I hope at least my post was relevant to what you're sharing.
Yeah.
I think the reason, a big part of the reason why I write is because I get a lot of questions. And, after a while, I just figured, hey, it's easier if I just try to answer all these questions in a blog post. So maybe a common question I get is, what's the difference between a data scientist, a applied scientist, a research scientist, ML engineer? I wrote that as a blog post. Another question I got was, how was your OMSCS experience like? I wrote that as a blog post. So I write it there, and it's very helpful for people. And a big unexpected benefit of writing it and putting it online, and sometimes randomly posting on other people's LinkedIn posts and maybe getting them upset at me, is that I make a lot of new friends. I can't remember when Daliana and I met, but from the first chat we had, since then we've always had a monthly recurring one-on-one call. And I've made multiple new friends this way online that has been very fulfilling. Alexei is another one, Goku is another one. So and it's just so much fun to get to know and meet all these like-minded people online. And I think I can't remember, I think Chip mentioned something. There was once I wanted to interview Chip for on my blog, Informal Mentors, and I reached out to her, and then through our chat, she said, hey, actually I read some of your stuff, it's really good, and that's the reason why I agreed to it. And I said, hey, it's because of you, this post that you wrote, that's why I wanted to interview you, that's why. And she mentioned that writing was very important to her.
Yeah,
she really enjoys writing, and it's really useful for her online, and I think that's a very big benefit of writing and sharing your ideas, your content. It could start small, maybe just a tweet. Or I know one thing that Daliana does very well is her LinkedIn content, right? Which is very helpful for people and helps a lot of people, and she makes a lot of new friends through that. And for me, I just tend to write on my site maybe once a week, or actually less often now. So yep, highly recommend that.
Yeah, thanks for sharing that. So what are something you learned in your career that you never learned in school?
In general, I think that in Korea, in most machine learning courses, you learn the ins and outs of machine learning. You learn how to split the model properly, what the different metrics are, and what the machine learning techniques are. And in Kaggle, you learn the same thing, and you get a lot of fast feedback. What I realized is that at work, often the most difficult part that trips people up is defining the problem. So, for example, let me give you a problem. Maybe you want to catch fraud. Okay, is it an outlier detection problem, or is it a classification problem? And if it's a classification problem, are we predicting if something is fraud, or are we predicting if something is not fraud? Depending on how you frame the problem, it affects the machine learning models you use. And then depending on which metrics you use, it affects your actual online performance. So this is the one thing that starts right at the beginning that has immense downstream impact on everything else you do. So that's one thing that we just don't get enough practice in online courses, because it's such an open space, right? The search space is so huge. Whereas in online courses at school, your search space is heavily restricted in a good way, because it gives you fast feedback. You iterate fast, you get a data set, you get a metric. So that's very straightforward. But in the real world, you know, where to find data, what metrics to use, how to define the problem, how the customer experiences it, that's very important. I think another thing that I learned at work that I didn't pick up in school or in online courses is that in online courses, you just write you write the code you need to get it working. But you can't do that in at work, right? So at work, you can write the code you need to get it working, you can get it deployed, but just deploying it is really just a start of the project. What's really important is maintaining it and upgrading, improving on it. So you need to write your code, design your systems in a way so that it's easily maintainable, easily operable. There's observability, you get notified, there's monitoring, easily extensible, and that takes a lot of effort. And that's not something that you learn at school, because how is someone going to provide you feedback with, hey, you know, this design is not extensible, or this code is not maintainable? Because in school you probably don't do code reviews. There's probably no requirement for code coverage or linting unless you actually do a course like that, but I'm not aware of any course like that. So that's one thing. And I think in school, you also don't learn about the operations of it. So what I mean is that, hey, if you're at work, use an Airflow pipeline, or use Spark, I'm sure you have come across errors every now and then, and you have to try to debug it quickly, triage it, debug it, and move on, and maybe write an error report. In school, you don't have that, because you don't have something live that's running in production. You don't have Airflow pipelines that are failing. You don't have Airflow pipelines that are failing because there's a leap year. You don't have SQL queries that are failing because the amount of data you accumulated because your business has been growing suddenly exceeds the capacity you have. So these are very real world, funny problems, tricky problems that occur that are just so unthinkable that it's just impossible for school or online courses to cover them comprehensively. So those are a couple of things that I learned at work but not at school.
Yeah, thanks for sharing that. And what are some mistakes you made in your career?
Well, you know, now that I think about it, I think it's generally hard for me to see of anything as a mistake. I think because I tend to always see it as a learning opportunity. I guess one mistake that comes to mind is the error where I sent the sample curl commands to the business and no one used it, right?
Yeah.
I think that's one mistake I made. I think a couple of other mistakes I made, I think I recall one now where my previous boss, a very great guy, I was giving a presentation to executives, you know, like how I would solve a product classification problem.
Yeah.
And I went through my slides. So here's the literature research. Here's what Walmart did. Here's what LinkedIn did. Here's what the data we have, the preparation we have. Here's how I would do it. Here's the machine learning models I'll use, etc., etc. And towards the end, and that's it. and I cannot remember how the execs looked back then, but I think they were really kind. They didn't stop me. They said thank you, and then they left the presentation. After that, my boss took me aside, and Eugene, that presentation really sucked. I mean, like, you talk about all this, but what's in it for them? What's in it for the business? He said that you should start with the exact summary up front. Like, say, we can solve this problem to 95% accuracy, and then everything else is in the appendix, right? You just say what you need to say in maybe 5 or 15 minutes, and the rest is just, if they have questions, they'll ask you questions. If they don't, you just save everyone time. I think that's one big mistake that I learned, and I'm very grateful for my boss back then who just took me aside and corrected me immediately. I think that's one mistake I made. Machine learning wise, maybe I make mistakes, but they're not as painful because I have this very lazy mentality whereby whatever I think I can do, I try to do it in half the time.
Yeah.
So even if I make a mistake, it's not so painful, right? Because I haven't sunk in that much cost, and I tend to fire multiple shots, and maybe out of I don't know, maybe out of 5 shots, 1 fails, 2 fails, but that's not so painful because I still have 3 shots, as opposed to someone who spends the entire year working on something, and if that fails, you have nothing for that year. So that's what I have.
Yeah, thanks for sharing that. And I don't think you're calling it lazy. I think it's actually smart, because I think sometimes it's really not productive to dive into a model and spend months to develop something without knowing whether it'll work or not. Why don't you just quickly put something together, something is not perfect, and then exactly using the lean startup approach in your machine learning model development cycle, and then iterate, fail fast, and see whether it works. And I think lazy is actually the source of a lot of great invention.
Yeah, I fully agree with that. And now that you mention it, I think I sort of recall where this mindset came about. This mindset of mine came about when I was mentoring 3 interns. And these 3 interns were only going to be with us for 3 to 4 months. And back then, my KPI for them, my personal goal for them was that I wanted them to do a solid project that they could put on their resume and help them get their first job. So you can imagine, in 3 to 4 months, there's not a lot of room to fail.
No.
So I had to very quickly iterate through multiple problem statements to make sure that I had one that I believed that they had a reasonable chance of success, and work on it for the rest of the 3 weeks. Because of that, and it's the same thing for the team. When I manage a team, it's very painful. You can imagine it's very painful when you're doing appraisal with someone, and at the end of the year, and they have nothing to show for it because they sunk so much time into a project that went nowhere.
Yeah.
And I wanted to prevent that from happening to my team. So I was like, I would always iterate quickly for them, even if every project in a year failed. At least there'll be 4 learnings, 4 lessons. They tried 4 things, and that's something to show. That's actually something admirable to show for, instead of having one project where they went too deep down a rabbit hole. And I guess maybe that's partially what guides my thinking, and also because I think I'm generally someone who's curious about many things and just wants to try many things.
Yeah.
I admit I'm just not someone who would dive very, very, very deep into natural language processing and just use the latest and greatest, but I'll just use something that's very efficient, maybe transformers via Hugging Face, that will work. Let's just do it, solve that problem, and move on. Because the way I see it, there's just too many customer problems to be solved, too many features I want to deliver to customers that I don't have enough time to work on them. So I just don't have the patience to dive into something so deeply when there's so many other things that I can solve.
Yeah, exactly. Because there's always a million things you can improve if you don't stop. So important to know the baseline of your model and to know how your stakeholder would like to measure success, and know when do you want to stop. I think we don't have to be the perfectionist. We can just execute, iterate, learn from the customer. And then I think perfection is achieved through multiple iteration. It's not you put your head down and then figure something out, give someone a surprise. Is usually not good.
Yeah, I agree on that. I think in most real world systems, I think perfection is very hard to achieve. I think in most, the saying is that really is relevant is that it's not the destination, but it's the journey, right? And in most machine learning systems, it's an ongoing journey until it gets deprecated or gets replaced by something new. But a lot of times it's really the journey that matters. There's no destination where you just stop. And if there's a destination you stop, it's probably just keeping the lights on, business as usual, and eventually about to be deprecated.
Yeah, I agree with that. So you write, you give talks. I ask my audience, what do they want to ask you about? They wonder, how can you be so productive?
Well, actually, a few people have asked me this, and it's no secret. I think from 2017 to 2019, I was working at Lazada and then a startup. So it's very intense. At a point in time, it was also when Alibaba acquired us. I had to fly overseas for weeks at a time to integrate Lazada with Alibaba. So it's very taxing. That was very taxing. And at the same time, I had to do that Masters of Computer Science at Georgia Tech. So that was done part-time. And truth be told, I'm not a very good student. And that took 30 to 40 hours of my time every week. I was very intense, very stressed out. Thankfully, my family and my girlfriend, that point in time, now wife, was very understanding. Essentially, on the weekends, I don't go out. At nights, I don't go out. I don't really have a social life.
Yeah.
At that point in time, I was just studying and doing the work. So what happened in 2020 was that I moved to Seattle, started my work at Amazon. And I felt it immediately, like all of a sudden I had so much spare time. I don't go out at night at that point in time. And on weekends, I was new here.
Yeah.
I had so much spare time. So I was like, okay, what is it that I should be doing? And I thought about it. Okay, let's try, since Amazon is such a writing heavy culture, let's try to improve my writing a bit more. Instead of writing monthly, I'll try to write once a week. And so that's where I poured my time into. And with work from home and the COVID lockdown, everywhere is closed. I just got more time to do that. So I started to be thinking about what should I be writing about. I have a lot of personal stuff that I would like to write about that interested. I also think a lot about other things like, and because I was previously having a very intense schedule.
Yeah, I think you didn't really try to be productive. You just followed your interests. When you're writing, sounds like of course, you want to share your wisdom with the audience, but you're writing for yourself.
One of my posts, okay, let's just imagine. I mean, people, at a point in time, so at the start of it, I had a mindset shift, which is that I thought that I had to write perfect stuff. I thought hearing about this, I was also learning about this note-taking approach called the Zettelkasten. And I was talking to my friend Gabriel, and he's like, how can I learn about this? And I wrote about it. So I just wrote about it online and just shared there. And for the longest time, nothing happened to it. And then someone posted it on Hacker News, and all of a sudden, it was like the top of Hacker News.
You got lucky.
Yeah,
again, by putting yourself out there.
Yeah, I got lucky and to be lazy. Someone asked me a question. I was like, okay, instead of answering you this question via Telegram or via chat, let me write it out. I can share with you the link, and then and that's how it happens.
Yeah. So the secret of being productive is try to be lazy.
To be lazy. Yeah.
I love that. And you mentioned through writing, you learned a lot of.
Yeah, I think one thing that a lot of people expect is that. So this is the question that when I have chats with people and they ask me, hey, I want to start writing, but I don't know what to write about. I don't know, what if no one reads my writing? What should be my niche? I mean, let me be brutally honest. I think for the first 10 or 20 pieces that you write, and then the other thing is, what should my niche be? Should I write about fitness, investing? Should I write about careers? And a lot of time, you don't find your niche finds you. So what I found in that 1 year of writing every week was that I just write a lot. And after that, when I look at the statistics, I look at what people resonated with. I found that I had this niche in more about machine learning system. Just pretend no one's reading and just write anyway. Eventually, people might read it, maybe. But the main benefit of writing is to yourself, is that you clarify. I think that I started investing pretty late. I started investing only 2 years of income. I started investing a lot of my income. And so when I wanted to leave the guidance was that, hey, I had a sizable amount of savings. I had a sizable amount, not sizable, but I had a decent amount in my investment portfolio that if anything goes wrong, if IBM fires me, I would still be okay. I just felt safe to do that. And because I had this cushion, it allowed me to do that. Yes, the opportunities came, but I have said no to it. And I think I would have said no to it if I was too risk adverse, if I had no cash reserves, if I was too worried that Lazada might fail, and where would I get a job? But to start early, which is compound interest investments in the total index right now is up more than 100%.
Yeah.
So starting early helps you to feel more safe, financial security, which allows you to take more risk in your career, and of course it allows you to retire happily.
Yeah, I agree with that. I think a lot of times when we get our paycheck, we just put it in the bank. But I think although we're data scientists, we spend a lot of time learning. It's also important to pay attention to, personal finance and invest. Like Eugene said, it kind of indirectly helps you with your career. Once you feel more secure, you can just join a startup, or maybe you want to start your own startup.
Or even start a startup. I mean, if you have enough reserves that you say, hey, if I only spend $2,000 a month, if I have 100,000 in reserves, that can last me 50 months, right? And you might take the leap and do a startup, or join a startup, or create a startup of your own. And because you have this your personal finances sorted out, it gives you the opportunity to do that, right? Yeah.
And you also talk about stoicism and meditation. How do those practices help you, your career or life in general?
Yeah, I think one problem I have is that my mind is a monkey mind.
Oh yeah,
my mind is.
So am I.
My mind is overly anxious about everything.
Yeah.
Overly nervous about everything. So I used to meditate maybe every day in the morning for 10 minutes, and that didn't really help. But last year, at the end of last year, I had 2 weeks vacation, and I had everything all planned out. I was going to do this. I was going to play a game, really immerse myself into it, just take a break. But it turned out that game sucked. Within the first day, I just couldn't play anymore. I mean, it was so bad. I had to return it. So now I had 2 weeks of time, and I had nothing to do. I had nothing planned. So I decided, okay, let's try this meditation. Let's give this meditation thing a try. I'm going to try it for 1 hour every morning. And in the past, I could not imagine wasting 1 hour of time not reading, not writing a draft, not exercising. But for this vacation, I had nothing to do. So I just tried it. And when I was doing it, I started to explore a lot about myself. I explored, hey, why am I so anxious about this? So maybe let's take an example. Let's take a topic that I explore a lot: hedonic treadmill. So I examine, why am I so anxious about this? Why do I want to get to the next level? Why do I want a bigger house? Why do I want a bigger car, for example? And I realized that it's just a hedonic treadmill. That once you get something, you just want more.
Yeah.
And I try to tie it back to my learning of evolutionary psychology. So this may or may not be correct, but it's just how I try to understand, in the sense that in the past, when we are cavemen and cavewomen, caveman just wants more resources, because if he has more resources, he has more meat, he has more shelter, he's able to get mates, and he's able to reproduce.
Yeah.
But in today's world, we don't really need that.
No.
We are able to really support ourselves and live very well. And I realized, oh my goodness, I'm on the hedonic treadmill. And I'm so anxious about this. I just want more and more. I do more, do faster, do better. That I just really didn't really enjoy my life. So, and it was through that meditation process that I learned about this. And since then, I've continued to try to meditate once every hour, and it's always been very enlightening for me. And I really treasure that, because if not, I would just be carrying these problems with me throughout the day. It would just be there in my head, affecting me. But if I take that 1 hour to just think it through, I would resolve it, and I was settled. So meditation has many kinds. Some of it is like, mindful meditation, where you focus on your breath. It helps you focus. For me, I try to, I do something called, I don't know what's the right term. I think it's insight meditation. I would try to take something that's bothering me, something that comes into my mind. I just keep asking myself, why, until I sort it out, and then I can let it go.
Oh, wow.
And then it just clears my mind and clears my heart, and it just makes it easier to live, I think.
Yeah. Thanks for sharing that. I think maybe I should also try that. About the revolutionary psychology, I recently wrote a post about, I thought I would be happy when I get promoted to level 5 and level 6, and then I realized after I get promoted, I'll be happy for a few days, and then I'll feel I'm not enough. I want to go to the next level, and there's always going to be another level. So I think it's also, Naval said, your desire is basically you prevent yourself from being happy, unless you achieve that, and you always gonna, it's like put your happiness on hold. So there's no way, no level is gonna make you happy. You have to be happy. Happiness is the way.
Exactly. And I think one video that I watched that was really powerful is from this guy called Justin Khan. He's the co-founder of Twitch.
Yeah.
So as a co-founder of Twitch, he sold Twitch for $1 billion, right? $970 million. And he was sharing that, he was advisor or partner at YC, Y Combinator. And he was seeing people, his friends, like Airbnb is I don't know how many $1 billion company. He's like, he was thinking, hey, I'm no worse than them. I can do that too. I want to build a $10 billion company, $100 billion company. And he tried that and it didn't work out. But along the way, what he learned is that, hey, this is just a never ending thing.
Yeah.
We keep wanting to achieve more and more and more and more, but what really matters on our deathbed? And so he was talking a lot about this hedonic treadmill, and that is now very apparent to me. Every time I see myself desiring something, am I desiring this just because it's a hedonic treadmill, or am I desiring this because it helps people? And I really try to distinguish between that. If it's just a hedonic treadmill, I just try to put it aside and not let it affect me.
Yeah, that's great insights. So before we wrap up, what do you think is the future of machine learning?
Yeah, that's a very tricky question. I'm no prophet, but what I can see is that I think a lot of machine learning is going to be automated, right? A lot of it would be, companies like DataRobot, SageMaker, H2O, they try to make it easy for you, whereby, you provide some data, you provide your labels, and they just auto-tune your machine learning models and deliver whatever is best. But what cannot be automated? What cannot be automated is defining what metrics to use, defining what data to use, what label to use, how to frame the problem. So I think that in 5 to 10 years' time, or maybe even earlier, a lot of most people wouldn't be doing machine learning as what we think of it now, which is hyperparameter tuning, feature engineering. A lot of it, we would just use things like Hugging Face or SageMaker. But what's really important, what's really difficult is to try to frame the real world problem as a data and machine learning problem, to try to find the right metrics for them. So I think that's what I think the future of machine learning would be like.
Yeah. So basically, there are going to be a lot of tools to empower data scientists and the machine learning engineers. But there's something that's not going to change is how you communicate with stakeholders, how you pitch your idea, how you give presentation. And those are the parts we mentioned earlier.
Fully agree with that.
Yeah. And what is something in your life or in your career you are excited about?
Well, I think right now, I recently adopted a puppy.
Oh, nice.
So I'm spending a lot of time with her, training her and bringing her on our hikes and everything.
Yeah.
So she's adorable. That's one. The other thing is that I think, with COVID a bit more under control, I really like that Seattle is opening up. So I'm, and today the weather is pretty good. I really like it that going out and eat again, socialize with friends again, and meet people face to face. Like I wouldn't be able to do this with Daliana if we were still in the lockdown. And I think one idea that Daliana and I have been thinking of is to think about how we could have more talks like this in a more informal manner, with maybe more audience participation.
Yeah.
Where we just take a topic and just share our ideas and opinions, and maybe have some audience ask questions. Maybe on a more freeform approach, maybe Clubhouse or Twitter Spaces, etc. So I think that's an idea that we'll be keen to explore. So
if you're interested, you can follow me and Eugene on Twitter, and also join our newsletter. We'll post those events probably in January 2022.
Yep, that's it.
Yeah. Well, this was really fun. I feel like I learned so much more from you about your machine learning approach and also you as a person. So thanks again for joining me in the show.
And thank you for having me here. I really enjoyed those questions. They were very thought-provoking and made me think hard about it. And I'm glad to be able to share whatever I know, what little I know with your audience.
Thank you.